Sorry about that. Apparently, I just have the sneezies. All right, so most of you said A. Good job. If you said A, congratulations. That is the correct answer. So remember the way we do it when we're multiplying exponents that have the same base? Yeah. We take x to the 5th times x to the 7th, and that is add the exponents. So we get x to the 12th. All right. So what are we going to do today? Well, today we are going to review and use the properties of exponents and Desmos to simplify some algebraic expressions. And we're going to use that information to then find equivalent expressions. Woo! Just use Desmos? Perfect. How you did it? No problem. I like it if you're using Desmos because Desmos is our friend. Yesterday we called him our bestie. My last class called him Key to Success, or called it Key to Success. All right, so here is a reference chart. These are the STAR reference materials. You will also have access to these on the STAR test. So I would recommend making sure you have access to them right now and make sure that you use it when you're taking tests and quizzes in this class. Okay, so again, some vocabulary. Power, this is also our exponent. In other countries, they do also call that the index, same thing. Right? Then we have the base. Remember, this is what the exponent applies to. And then we have the coefficient, which again is just defined as the number in front. Now, one question, it's just thumbs up or thumbs down. Thumbs up for yes, thumbs down for no. Do you think that in this example that is on the screen, 2x to the 7th, does the 7 affect the 2? Does the 7 affect the 2? Okay, so most people are saying yes, but in this case, the exponent does not affect the 2 here. Okay, here the exponent is only the 7, or to the x, sorry. If we wanted the exponent to apply to the 2, oops, I put my 7 in the wrong spot. In this one, the exponent applies to the 2. Okay, so does everyone see the difference between this expression and this expression down here, the top expression and the bottom expression? The exponent only affects what it's actually touching, the base it's touching. So if it's not touching the 2, then it doesn't apply to the 2. With the parentheses, that means 2x's all together, so the 7 would be touching. Okay, so just to keep that in mind. Mostly that's going to help you figure out if answers make sense. Yes, it affects the x, but not the 2 in the expression here. But if it had parentheses, then it would affect the 2. And that's actually really important when you get to things like this. If you have -2 squared, the 2 doesn't apply to the negative because the negative is not inside parentheses with the 2. Now it does. Okay, so it's very important to be cautious and enter everything into Desmos, especially if you're using Desmos, exactly as you see it. All right. All right, so we have our radical expression vocabulary. Okay, so -2, the negative in front of the 2 just means the opposite of that number. So the negative doesn't apply to the exponent. It only applies to the answer. So it is like saying this, like that. That's why it's important to, if you're using the calculator, to make sure you're paying attention, that what you're typing in matches what you see. Because usually if you type in what you see, the calculator knows what it's doing. Okay. All right, so index, this is the number inside the little v of the radical symbol. Another word for radical symbol people would use is square root sign. Usually if we see it without an index, we just say square root. Radicand is the term inside the radical. We very rarely use that, and I have never used it outside of this class or outside of math class, so that's good. So here's the next question, and you'll answer in chat in 1 moment, okay? So you can type the answer, but don't hit enter yet, all right? If there is no index, and I'm putting in parentheses because it's implied. If you add salt to coffee, it actually decreases the bitterness. I know that's weird. All right, guys, so in chat, and I want everyone to type it, but don't hit enter. I'll have you enter at the same time, okay? If there is no index, if there's no number inside the little v, so pretend that there is nothing here. If there's nothing there, what do we assume the index is? All right, so type a single number in chat, and then 3, 2, 1, enter. Perfect. We do actually have a pretty good consensus, and the consensus is accurate. If there is nothing there, then we understand it to be 2. Okay? This is what we call invisible math. If there's no number in front of a variable, it's a 1. All right? But if there's no number in an index, it's 2. All right? And that's because this symbol by itself is read as square root. So if square root, the exponent to make something squared is 2. The radical undoes an exponent. The index matches the radical or the exponent, okay? Everyone understand why there's a 2? Why we pretend there's a 2 there? Thumbs up if you're good with why there's a 2 there. Most of the time in this class, we are just going to pretend there's a 2 there, okay? So for this one, we're going to say thumbs up. This one is going to be the heart. And this is going to be the laughing emoji. I don't know how to draw that. So what do we call the number or expression inside the radical? What do we call the number or expression inside the radical? What do we call it inside? Okay, so this one, this is put the laughing emoji, because why not? Oh, I can react. I can put emojis up. Okay, cool. Yes, this is a radicand. I don't like using the thumbs down one as an answer choice unless the answer is no or false. Right? Which one is the small number written just outside and above? Perfect. That's our index. And then, of course, the last one is radical expression. It's a blue widow. It's not a good spider. Don't worry. I am not an artist. That's why I teach math. All right. Sorry. What's the index here? Just put it in chat, guys. I don't need you to put it in a text poll. That's silly. I find that sometimes silly. That is right, Riley. Good job. It is 3. Awesome. There's the index. Perfect, guys. Awesome. Good job. You guys are so participatory. I love it. We have 60 people in here, including me. That means 59 of you showed up. Okay. So don't worry about this async it because that's not the one you're going to do. That's for if people are not here, they can do that one. Those of you who are here, it's more fun to play together. I'm going to turn on the exit ticket so you can answer it if you want. I'll go ahead and do it by hand. You guys can do it in the calculator if you wish, and then I'll run it through the calculator as well. So what I like to do when I do these kind of problems is I break things down into smaller pieces. So like I'm going to take the 16 over 4, and then I'm going to take the k, or the k, the m, over the n. Normally I would not be using red and green this close together, but it is what it is. All right, so we have 16 over 4, k to the 9th over k to the 3rd, and then m to the 7th over m to the 14th. Right, and we subtract when we're dividing. So k to the 4th, or sorry, 16 over 4 is 4. K to the 9th over k to the 3rd. Remember, we subtract. Subtract again here. All right, so we have 4. Awesome. Thanks, Ozzy. K to the 6th, m to the negative 7. Notice how none of these have negative exponents, though. Remember, negative exponents go in the opposite side of the fraction bar. So this is our answer was B. And then if you're putting it into the calculator, again, you'll set a value for each variable. Usually better to not use 1. You don't want to use 1, and you don't want to use 0. But 2 and 3 is good. 2 is a little sketchy sometimes, but 2 and 3 should usually work. And then you just compare the answers. So you type it in just like you see it and compare the answers. Okay? Does anyone have any questions they need from anything else they need from me today? Any questions, comments, concerns? I'm gonna post this image to. Oh, I'll leave it open until 11:30. No worries. If you have no questions, you are free to sign out, though. You do not have to stick around. Have a good day, guys. And here are your reminders for the week. I'll just keep them up.